Hey, what's going on, guys? Today we're going to prove that e is equal to the limit as h goes to 0 of 1 plus h raised to the 1 over h. Okay, so this guy right here is going to 0, and this guy right here is going to infinity. Okay, so first we're going to define some things. We're going to say let f of x equal ln of x. F prime of x is going to equal 1 over x, and f prime of 1 is just going to equal 1. Okay? So first we're going to start by taking the derivative of f of x, and we're going to do that by using the definition of derivatives, which just is a limit, and we're going to evaluate that limit at x is equal to 1. Okay, so maybe I'll do it over here. So we're going to have f prime of 1 is equal to the limit as h goes to 0 of ln of 1 plus h minus ln of 1 all over h. All right. Right away we see that this ln of 1 is going to go to 0. Okay. Well, hopefully you see it. And we are left with f prime of 1 is equal to the limit as h goes to 0 of ln of 1 plus h. And I'm going to take this h and recognize that it is just 1 over h multiplied by ln. And so because it is, I can bring it up into the exponent slot here. Okay, so hopefully that didn't confuse you. All right, so we're actually getting pretty close. And we recognize in the very beginning that f prime of 1, which we're talking about right now, is equal to 1. All right, so now we have the limit as h goes to 0 of ln of 1 plus h, 1 over h is equal to 1. And now we're going to exponentiate both sides. So I'm going to raise both sides to e. Okay? So we're going to have e to the limit of h goes to 0 of ln of 1 plus h, 1 over h is equal to e. Now by the properties of limits, I can bring this guy down out in front of the e. Running out of space here. Let's see, the limit is h goes to 0, e to the ln of 1 plus h, 1 over h is equal to e. And maybe I'll prove this on the side real quick, but we know that if e is raised to ln of something, forgot my 1, something, then that's just equal to that something. So yeah, I'll put this on the side here. So if we have maybe y is equal to e to the ln of x, that's something, right? And we take the logs, or ln of both sides, is equal to ln of e to the ln of x. Well, by the properties of logarithms, that ln of x can just come right down. So ln of y is equal to ln of x times ln of e. This guy right here goes to 1, and y must equal x for this to be true. So y is equal to x. Okay, so maybe just to finish this out right here, this right here is equal to the limit, still the limit, right, as h goes to 0 of ln, no, not ln, of 1 plus h to the 1 over h, and that must be equal to e. Okay. Maybe another note that sometimes you'll see this written as the limit as n goes to infinity of 1 plus, or maybe I should say h, stay with h's, 1 over h to the h, and that's equal to e as well. Notice this is going to 0, this right here is going to infinity. If it's written like this right here is going to 0 still, and this right here is going to infinity. Okay, that's all.